understanding reflection and refraction of light. So let us begin by discussing reflection of light. Okay, and in order to have reflection of light, we must have reflecting surface. So this is reflecting surface. Okay, so this is reflecting surface, or this is mirror. Okay, we have this. Now I'm drawing normal to the surface. Okay, so this is normal, this is normal to the surface. Now let us consider incident ray. Okay, so this is what, this is incident ray, and let the angle of incidence be I. And let us consider incident ray moving in air. So we have this, and we know the speed of light in air or vacuum is c, and c equals 3 times 10 power 8 meter per second. So we have this. Okay, so as I said earlier, this is incident, so this is incident ray. So we find incident ray traveling in air with speed equals 3 times 10 power 8 meter per second. Okay, so after striking the mirror or reflecting surface at this point, it is reflected back, okay, into the same medium. So this is called angle of reflection. Okay, and this is reflected ray. Okay, and reflected ray is in air. Okay, it is in air medium, and it also travels with the same speed, that is 3 times 10 power 8 meter per second. So we have this. So what we find in case of reflection is that, okay, so I'm writing in reflection, okay, of light, both incident, okay, both incident and reflected, okay, reflected rays are in, okay, they are in same medium. So we find this. Okay, so this is for reflection of light. Now let us discuss refraction. Okay, so refraction of light, and to have refraction, okay, to have refraction of light, so I'm writing, to have refraction we must have two transparent medium. Okay, so I'm writing refraction occurs in any two transparent medium. So we find this. Okay, so we can have any number of transparent medium, but minimum, so this number, okay, this is the minimum number of medium. So this is to be noted. Okay, now let us consider this case. Okay, let's say this is denser medium, this is denser medium, and this is rarer medium, and this is the boundary separating denser with rarer. Okay, so we have this. Then what we find, refractive index of denser medium. Okay, let's say this is medium 1. Okay, this is medium 1 and this is medium 2. So refractive index of denser medium is mu 2, and refractive index of rarer medium is mu1. Okay, so what we find is that, okay, we find refractive index of denser medium is greater than refractive index of rarer medium. So this is to be noted. Okay, so we find this. Now this is normal, okay, to the surface, and this is incident ray. Okay, so this is incident ray, and this is angle of incidence. So we have this, and we find that, okay, incident ray is in rarer medium, and we can take rarer medium. For example, we can take this as air. Okay, and we can take denser medium. For example, we can take this as glass. So we can have this. Now what we find when we take air, okay, when we take air, then we find incident ray, okay, moves with speed equals, so I'm writing in this way, it moves with speed 3 times 10 power 8 meter per second. Okay, so we have this. Now we find the incident ray after suffering refraction at this point. Okay, so it suffers refraction at this point, or it suffers refraction in this boundary. So we find it bends towards normal. So we find this. So this is refracted ray. Okay, this is refracted ray, and as I said earlier, this is incident ray. Okay, so this is incident ray. So we have this. So what we find is that, okay, we find the refracted ray bend towards normal, okay, when we have incident ray in rarer medium, and when it is suffering refraction in denser medium, and this is angle of refraction. So we have this. Clear? We have this. So we have this. Now we find the refracted ray bend towards normal. Clear? So what we notice in this case is that, okay, in refraction, so I'm writing over here, in refraction, in refraction, incident and refracted rays are in different medium. So we find this. So when you compare reflection with refraction of light, in reflection, okay, both are in same medium. Okay, whereas in case of refraction, incident and refracted ray are in different medium. So we find this. Okay, so we find medium is different. Now let us discuss this also. Okay, let's say we have incident ray in denser. Okay, this is denser medium, and we have this. Okay, incident ray moving in denser medium. So this is incident. Okay, this is incident, this is I, angle of incidence, and this is rarer medium. So this is medium 1 and its refractive index is mu1. Now we find this ray of light after suffering refraction bends away from normal. So this is angle of refraction. So we have this. So when we look into this figure, we find incident and refracted. Okay, we find incident and refracted in different medium. So what we can conclude is that incident and refracted ray, they are not having the same speed. So what we find, so we can conclude in this way. Okay, speed is different in refraction. So we have this. So this is to be noted. Okay, we find speed of incident is not equal to the speed of refracted ray in refraction.